Hey guys, and just want to take a moment here to talk about how we can translate what we're doing with these clusters, and when we drag and add and subtract and delete these different counters, how we can take all of that math that we're doing here with just kind of intuition and translate that into kind of more formal math language in the form of actually writing equations. So first things first is, how do we take this situation and translate it to an equation? Well, for instance, on this left cluster, I see an x, I see a negative x, negative x, negative x, so minus 3x. I see negative 1, negative 2, negative 3. And I see positive 1, 2, 3, 4, 5. So we might write this left cluster as x plus negative 3x plus another negative 3 plus a positive 5. And so this mathematical expression right here might capture, or this is how we would capture this situation with more formal math writing. And of course, what this is going to be equal to is some other expression. And on the right cluster, we have positive x and positive x, so positive 2x, and 1, 2, 3, 4, 5, 6. So we might write this right-hand side as 2 times x, 2 x's, plus a positive 6. And of course, here we have an equation now. An equation is any time you have a mathematical statement with an equal sign. And you're going to have probably at least one unknown variable here, in this case, the unknown variable x. And what we're going to be doing here, both with these counters and with this formal math language, is we're going to solve the equation. And what does it mean to solve an equation? To solve an equation means find the value of this unknown variable or unknown variables such that if you were to substitute that value back into this original equation, you would have a true statement, something like 17 equals 17 or who knows what. So what we're going to do is we're going to actually go through the motions with the counters and show how that would translate into this more formal math language. So here we go. The first thing I think I would do is in this left cluster, I see we have a positive x and a negative x. I think those two add to 0. So I'm going to go ahead and get rid of those two. So what would that look like up here? Note that we're left with a negative 2x. Up here, I think we'd say, well, positive x plus negative 3x. I think these are going to combine together to give negative 2x. So I might write the next line of this equation as negative 2x minus 3 plus 5 equals 2x plus 6. The only thing we did is we combined these two terms, if you will, and instead of having a positive 1x and a negative 3x, now we just have a negative 2x. Every time we do any kind of manipulation, or we really do anything with our counters or to either side of an equation, we're going to want to write that as a new line directly below so that it's super easy for the reader to follow exactly what we did. And this is really, really important. I also took a moment to show that you can write this as adding negative 3, or you could just say that you're subtracting 3. So you could have written this as negative 2x plus negative 3, or just negative 2x minus 3. The next thing I want to do is I see I've got a negative 1 and a positive 1, a negative 1 and a positive 1, a negative 1 and a positive 1. I think all three pairs are going to add to 0. So let's go ahead and simplify that. Just fewer things going on, definitely going to make life a little easier. And up here, I think you can just say that, well, listen, negative 3 plus 5, that's 2, just like what we ended up with here. So I might write the next line of this equation as negative 2x plus 2 equals positive 2x plus 1, 2, 3, 4, 5, 6. So we really haven't done anything with this right cluster here, and that's why the right side of this equation hasn't really changed at all. But at least we took the left-hand side. I think we made it into something a lot more manageable. Okay, so what do I want to do next? Maybe what I'll do is, I see we've got these negative x counters here on the left-hand side. I don't really like those. I'd rather have all of my x's kind of on one cluster. So maybe what I'll do is I'll take a pair of positive x's. I'll add a positive x here and a positive x here. That's okay because I did the exact same thing to both clusters, so everything remains balanced. I'll add another positive x to the left cluster and another positive x to the right-hand cluster. And the point of me doing that was that these two pairs are going to each add to 0. So it makes the left-hand side have a little bit less going on, and that is awesome. How might I write that here in our equation? And I'm actually going to handwrite this. Is what I think we did is we added positive 2x to both clusters. And in our equation, we would write that as adding 2x to both sides of the equation. And this is how I like to write it. You're saying, hey reader, listen, on the left-hand side of this equation, and this left cluster, I have added a positive 2x, but I've done the exact same thing to this right cluster, to the right side of the equation, so everything remained balanced and everything is groovy. I did this in blue just for dramatic effect to kind of draw your attention to it. And so now we are left with an even simpler situation going on here, an even simpler situation going on here. I think what our equation has simplified to is now just 2 equals positive 1, 2, 3, 4x. Plus 6, right? Negative 2x plus 2x, these add to 0. That's nice. 2x plus 2x adds to 4x. So our equation now looks like 2 equals 4 times x, so 4 x's, plus 1, 2, 3, 4, 5, 6. Amazing, amazing. All right, we're almost there. So now looking at these clusters, what I'm thinking is it would be a lot easier if I just had only x counters on one side and then, positive ones and negative ones or whatever on the left-hand side. So here is what I'm thinking of doing. First, I'm thinking, well, I see a positive 1 here and a positive 1 here, another positive 1 here and another positive 1 here. So I'm going to go ahead and subtract 1, boom, boom, from both of those clusters. Since I did the exact same thing to both sides or to both clusters, everything is groovy, everything's still balanced. So right now we kind of have taken away 2 from both sides. So our equation might look like 0 equals 4x plus 1, 2, 3, 4. But I want to go even bigger. I don't have any more positive 1s to take away here because I really want to kind of get rid of these guys and have just x's. But what I can do is instead of subtracting a 1, I can add in a negative 1. Boom, look at that. These two right here, add to 0, boom. Add in a negative 1, add in a negative 1, boom. These guys add to 0, boom. Add in a negative 1, add in a negative 1. Always doing the exact same thing to both sides of the equation. That's really important, so that it remains balanced. Boom! And now look, we've got a situation in which I have only x's on one side of our cluster and only numbers on the other, and that's really, really valuable. So what we've actually done from this point, where we were a little while ago, is I think we've actually, you could say we added negative 6 to both sides, or we subtracted 6 from both sides. And so that's kind of what we did here with the counters, and how we would write that here is, well, we would say, what we're going to do to both sides of the equation is we're going to subtract 6 from the left-hand side, subtract 6 from the right-hand side, make it very easy to the reader. I tend to put this below my equation line. You are also welcome to put it at the side if you'd like, if that's easier for you. And what we have now is a new equation, negative 4 equals 4 times x. All right, so we've got negative 4 equals 4 times x. All right, and we're almost done. And I think you can see that if I have 1, 2, 3, 4 of these x counters and 1, 2, 3, 4 of these negative 1 counters, I'm thinking that each one of these x counters is probably has a value of negative 1. I mean, this is kind of intuitive. You can kind of just see it. And so what I might do is I might say, you know what? Of both of these clusters, I'm going to keep just 1/4 of them and get rid of the other 3/4. So I've kind of visually lined this up into breaking it into quarters, and so let's get rid of everything but 1/4. So we're going to keep 1/4 of the left cluster and 1/4 of the right cluster. We've done the same thing to each of the clusters, so that's groovy. How would we write that over here? 2 ways of doing it. You can say that you've kind of taken both clusters and divided them into 4 pieces and just kept 1, so you kind of divided by 4. So this is one way to write it. You could say divided by 4 on the left-hand side and divided by 4 on the right-hand side. And not surprisingly, you end up with a solution, a final answer that negative 1 is the value of that unknown variable x. Another option, and the one that I actually like the most, is instead of dividing by 4, I prefer to say that what we actually did was we multiplied by 1/4, right? We kept only 1/4 of each of these clusters. So I might say multiplied by, and I'll write 1/4 as best I can. So we multiplied the right-hand side of the equation. We have taken 1/4 of the right cluster, and we're going to do the same thing with the left cluster. We are going to take 1/4 of whatever was there, and I'm actually going to put in another set of parentheses around this negative 4, otherwise it might look like subtraction, and same outcome. We find that the value of our unknown variable x is negative 1. So we think that the solution to this equation, our original equation up here, was negative 1. We did so intuitively. We also showed how to kind of notate this formally. But let's actually substitute this back in to make sure, right? The idea is solving an equation means finding the value of x such that the equation is made true. All right, so if x were equal to negative 1, I'd have negative 1 plus 3, which is positive 2, minus 3, which is now -1. -1 plus 5 is +4. Okay, so if x were -1, the left-hand side would be 4. 2 times -1 is -2. -2 plus 6 is 4. Holy cow. If x were equal to -1, the left-hand side of this equation would be 4. The right-hand side of the equation would be 4. We'd have a true statement. This is the solution to our equation. So what I hope you've taken away from this is how do we use formal math notation to show what we've done here, and how we can take an equation like this and solve it using this notation. And eventually we're going to kind of stray away from these counters and this representation, and we're going to kind of focus on this representation a lot more. So I want us to be really good at using this representation and this notation, but I want what we do here to be grounded in the intuition that we developed here. So, all right, thank you so much.